Today we're doing section 2.1, day 2, complex numbers. Today we're going to focus on the division of complex numbers. One thing we need to discuss is the vocabulary word of the word conjugate. So the conjugate is if I have a complex number, a plus bi, the conjugate becomes a minus bi. So notice the part that is imaginary is the part that the signs flip. The real number stays the same. So for our first example, we're going to multiply top and bottom by the denominator because that's where the imaginary part is. So the conjugate will become 2 minus I. To keep things balanced and equal, I have to multiply the numerator and the denominator by the conjugate. So in the numerator, I'm going to distribute, and I'll have 8 minus 4i. In the denominator, I have to FOIL. Now, a little shortcut for the conjugate. Because we picked the conjugate, the inner and outer terms are always going to cancel. So it's just going to be the first and the last terms when I FOIL. I squared is equal to negative 1, as we know. So I have 8 minus 4i. Then the bottom will be 4 minus a negative 1, which turns into 4 plus 1. So the denominator will be a 5. No reducing can happen here, so that is our final answer. Letter B, we're going to multiply by the conjugate again of the denominator. So we change it to be plus 5i. All right, so we're going to FOIL top, FOIL bottom. So for the top, I'm not sure why that's not writing. You get the idea. All right, so for the top, we'll have 14 plus 35i plus 8i plus 20i squared. For the bottom, we'll have 4, and we know the inner and outer will cancel, and then I'll just be left with 25i squared. So in the numerator, I have 14 plus 43i, and then this will change to be minus 20, all over 4, and this will become 4 plus 25, so all over 29. And then I can combine the 14 and the 20 in the numerator, and we'll get negative 6 plus 43i, all over 29. And that's as far as we go. Again, I would check to see if all three numbers reduce. In this instance, they do not. So go ahead and try that practice problem. Make sure you input it on the video. So square roots of negative numbers, so just a little recall. If you have the square root of a negative 1, that is where the I is coming from. So the I will always replace the negative underneath a radical. So for some simplifying here, we discuss perfect squares, so 9 and 2. We could say that's a negative 9. For 8, it would break down to be 4 and 2. And we're taking the square roots of all of these values. So this will become 3i square root of 2 minus 2 root 2. Now, because the radicals are the same, typically you can combine the outside numbers, which would be the 3i and the negative 2, but in this instance, one is imaginary, one is real, so you can't actually put them together. So this is as far as we can go. For letter B, we would write this twice, and when we write it twice, we're going to clean this up a little bit. So we're going to write I root 5 rather than leaving it as the negative 5, and then we're going to FOIL. So first term will be 1. Then I'll have a negative I root 5. I'll have another negative I root 5. And then we'll have plus I squared square root of 25. And it looks like I ran out of room. 25, there we go. All right, so I have 1, then I'll have minus 2i root 5s. The I squared will become negative 1, and the square root of 25 will become 5. Notice it's still multiplication just like it was before. So when I multiply these, I get -5. And now I can combine the 1 and the -5 and get -4 minus 2i root 5 for my final answer for that one. We have one more to go over. So letter C, we're kind of setting you up to go over quadratic formula for tomorrow's video. So today we're just going to do a quick recap on breaking down and simplifying. So first thing I'm going to address is this -50. So -50 can break down to be -25 times 2. So this will become 5i root 2. Now that I know that, I'm going to come back into the problem. So the -25 is still there, plus 5i root 2 all over 15. So the three numbers on the outside, the 25, 5, and 15, can all be reduced by a unit of 5. So it'll be -5 plus 1i root 2 all over 3. And notice we don't ever touch the number underneath the square root when we're doing simplifying of the outside coefficients. All right, that's all for today.